Okay, we're in section 4.5 today. And this section we're going to be solving some exponential or logarithmic equations. So we looked at simplifying log expressions and exponential expressions. Now we're actually going to have an equation and we're going to be solving for the variable. So we're going to start with some exponential equations. The first theorem or property you need to know is the equality of exponents theorem, which we've used already. Basically, it says if you have two values with an exponent and the bases are the same, so you can see here we have b to the x equals b to the y. Both of them have a base of b. If that is true, then we can say that x has to equal y. So that's the idea we're going to be using with exponential equations. We want to rewrite the expression so that the bases are the same. Okay, and remember the base has to be greater than 0 and the base will not be equal to 1. So keep that in mind as you're going through these. All right, so here's the idea. We want to rewrite the equation so that each side has the same base. Once we have that, then we can set the exponents equal to each other and solve for x. Okay, so here's our first one. We have 3 to the power of x minus 2 and 81. So looking at these right now, 3, I can't write 3 as any other value with an exponent, but 81, according to this equation, should be some power of 3, which it is. So 3 to the x minus 2, 81 is 3 to the 4th. Now, if you don't know that, again, you could look and say, okay, well, this one's 3, I can't do anything with that, but let's start multiplying. 3 times 3. 9, 3 times 3 times 3, 27, 3 times 3 times 3 times 3, 81, and just find different powers of 3 so that you end up with the same base. So using the equality of exponents, we have the same base. That means that our exponents must be equal. And then we can add 2 to both sides, and our solution is x equals 6. So simple as that. Now, sometimes you can't look at one or the other side of the equation and realize what base you're looking for, because maybe both of them have something you can write as a base. So I picked this one because it's kind of similar, because it's going to use the 3 again. And we already talked that 3 times 3 times 3 is 27. And we know 81 is 3 to the 4th. So I can rewrite this as 3 to the 3rd power to the x minus 1 power. And 3 to the 4th times 2x. Okay, so when we have a power raised to another power, actually I wrote this one wrong, it should be like this. Then we multiply the two powers together. So this is 3 to the 3x minus 3. This is 3 to the 8x. And now our bases are the same, so the exponents have to be equal. So 3x minus 3 has to equal 8x. We can solve that equation. So we'll subtract 3x from both sides. Get your x's together. So we got negative 3 equals 5x. And then we just need to divide by 5. So our solution here is x equals negative 3/5. Okay, so get your bases the same, and then the exponents have to equal each other. All right, if we have a expression like this where we can't get the bases the same, so remember we used, in the last section, we used the change of base formula. Let me fix my text here so it looks nice for you guys. So we're going to rewrite this. If you can't rewrite this, so if I look at this, I can't write 40 as a power of 5, because again, 5 squared is 25. 5 to the 3rd is 125. Can't get anything where 40 is a power of 5. So I'm going to write this as a log expression. So remember, it's the log of the base of 40 equals the exponent. The answer is always the exponent. So remember that. This was from section 3 when we rewrote these. Now we can use the change of base formula to solve. Okay, so that was from the last section. So remember, we're going to rewrite this as the log of 40 divided by the log of 5. Now, pay attention to the question. This answer, as the way it is right now, this is the exact answer. So if the question says find the exact answer, you would leave it like this. If the question says round to the nearest hundredth or thousandth or 10,000th, that's when you would put it in your calculator and get an answer. So we're going to do that as well, just so you can see what it is and make sure that you're doing it correctly on your calculator. So if I put this in my calculator, I'm going to get x equals 2.2920. Okay, so you might want to just double check and put it in your calculator, make sure you get the same answers so you know that you're entering these in your calculator correctly. All right, so that's our exponential equations, or solving exponential equations. I'm going to look at solving, oh, I guess I had one more example here. Sorry about that. So here's a situation where we have exponents on both sides, variables on both sides in the exponent, and we need to solve for the exponent. Okay, so we had this property back in the last section. I said we'll use this later. So it's later. So here we go. So if two things are equal, if m is equal to n, then the log of m and the log of n would still be equal. So basically, if two things are equal, we can take the log of both sides. And notice here it tells you leave this in log form. So for all of these, your answer will be in log form. Okay, so 3 and 5 have no common basis, so we can't rewrite either one. So we're going to take the log of both sides. So the log of 3 to the x equals the log of 5 to the x plus 2. So we're going to use our log properties now. We're going to bring the exponent out front. So we have x log 3 equals x plus 2, that whole quantity, times log 5. Okay. So we're going to distribute this on this side with the log 5. So you get x log 3 equals x log 5 plus 2 log 5. Now we need to get the x's by themselves, or we need to solve for x. So we've got to get all the x's on one side of the equation. So we're going to subtract this x log 5 from both sides. And let's move this up just a little bit. So that's going to give us x log 3 minus x log 5 equals 2 log 5. Okay. So both these have a factor of x, so we can factor that out. So this is x times log 3 minus log 5 equals 2 log 5. And finally, we're going to divide by this amount, just to get the x by itself. So if we divide both sides by log 3 minus log 5, then we get our final answer, which is x equals 2 log 5 over log 3 minus log 5. And that is your answer. So some people might want to say, oh, I can cancel out a log 5. There's a log 5 in the top, there's a log 5 in the bottom. Well, but those are both not factors. The log 5 in the bottom is being subtracted. It's not being multiplied. So it's not a factor, so we can't cancel them out. So we just leave it the way it is. Okay? So again, these types of problems where you're going to have an exponent on both sides and you can't rewrite either base, you're going to end up with an answer in log form. Okay. All right, let's take a look at the second one. So the second one, same type of thing. We're going to start by taking the log of both sides. So we've got the log of 2 to the power of 2x minus 3 equals the log of 6 to the power of negative x minus 1. So we're going to do the same thing again. We're going to use the power property of logarithms, which says I can bring the exponent out front. So I can rewrite this. Slide over just a little bit. I can rewrite this as 2x minus 3 times log 2 and negative x minus 1 times log 6. And again, excuse me, again, we're going to distribute. So we get 2x log 2 minus 3 log 2 and negative x log 6 minus 1 log 6. Let's just put that 1 like that so we can tell the difference. And remember, you want to get all the x's on the same side of the equation. So we're going to take this minus 3 log 2, and we're going to add that to both sides. We're going to take this minus x log 6, and we're going to add that to both sides. So that gives us 2x log 2 plus x log 6 equals 3 log 2 minus, I'm going to just drop the 1, just write it as log 6. You don't really need the 1 there. And then we need to factor out our x, just like we did before. So both these terms have an x. We're going to factor out the x from both of these. So I'm left with 2 log 2 plus log 6. And this side didn't change. And then just like we did before, we're going to divide by this whole value that we have left after we factor out the x. So our final answer is going to be x equals 3 log 2 minus log 6, all divided by 2 log 2 plus log 6. And again, there's nothing to cancel. Don't try to cancel anything out. Don't try to simplify. Just leave it like that. For these questions, again, they will be in log form, and you will always get a fraction as your answer. Okay. All right, let's move on now to log equations. So the exponential equations, if we needed to, we rewrote them in log form. The log equations, if we need to, we're going to rewrite them in exponential form. So they're, again, these are inverses, so we can just do the opposite. Okay. So rewrite in exponential form, then solve for x. So this is log base 10, remember that. And remember, the answer is the exponent. So this would be 10 to the third power equals 9x plus 1. If you need more practice rewriting exponents as logs or logs as exponents, I can send you plenty of worksheets on that. Just email me and ask me for that if you need to. So 10 to the third is 1,000. And we can subtract this 1, so we get 9x equals 999. And then if we divide by 9, excuse me, x equals 111. Simple as that. All right, number 2, a little bit simpler because we just have an x. We don't have a whole expression. So again, our base is 3, our exponent is 4. So 3 to the 4th equals x. 3 to the 4th is 81. And we're done. So some of these, even though they might look a little complicated, they're not as complicated as they seem. So make sure you don't overthink these and do too much work. All right. Rewrite as an exponent equation. Notice it says combine logs first. So if we have two logs together on one side, we can use one of the properties to combine them. So this is a log plus a log. So this would be the log of x times x plus 15. So we can multiply those two together. Equals 2. So we've got a single log. That's what we want. Now we can write it as an exponent. So remember, this is log base 10. So I'm going to multiply this out. This is x squared plus 15x equals 10 to the second power. Remember, your 2 is your exponent. So we have an x squared. That's our clue that we need to factor. So 10 squared is 100. So I'm going to subtract that from both sides. And we're going to factor this. So factors of negative 100, they give me 15. Well, 100 is 20 times 5. So x plus 20 and x minus 5. And if we solve both of those, we get negative 20 and we get 5. So x could be either negative 20 or 5. Now, here's what you need to remember. We did this with domain of a log. You cannot take the log of a negative number. So if I go back up here to my original equation and take my answers and put them back in, if I put in negative 20, that's the log of negative 20. Or if I put it in over here, that's a log of negative 5. I can't do that. So negative 20 is not a good answer. My only answer here is x equals 5. So make sure you don't end up taking the log of a negative number. Even though you got an answer, doesn't mean it's a valid answer. So be sure and check those. Okay. All right, this last one is the other property that we had. So we said that if two things are equal, then their logs are equal. Now basically, if their logs are equal, then those two things are equal. So if the log of one value equals the log of another value, those two values have to be equal. So first thing we need to do here is we need to combine these two logs together using the properties. So they're being added, which means I can multiply them. So this is the natural log of 2x plus 2 times x minus 2. And that equals the natural log of 3x plus 8. So I have one log equal to another log. That means the two values have to be equal. So 3x plus 8 has to equal 2x plus 2 times x minus 2. So basically, you can think of it as you're just dropping the log part of it and keeping the values because they're equal. Okay, so we need to multiply this. So if we FOIL it, we're going to get 2x squared. Let's see, we got a minus 4 and a plus 2. That's minus 2x minus 4. And again, we need to get it all on one side. So we're going to subtract 3x and we're going to subtract 8. So I get 0, equals 2x squared minus 5x minus 12. So remember, we got a factor, and because we got this 2 here, we would probably want to use slide and divide. Whoops, went a little bit too far. We're going to bring this 2 over here and multiply. So we got x squared minus 5x minus 24. And that's going to factor to x minus 8 times x plus 3. Remember, once you factor, then you're going to bring that 2 back and divide. So we're going to divide both of these by 2. So we get x minus 4 times x plus 3 halves. And that's going to give us a solution of either 4 or negative 3 over 2. So remember, make sure you go back and check these. If I put 4, write these over here. 4 and negative 3 over 2. If I put 4 into any one of these, I think the only one I got to worry about is this last one. 4 minus 2 is positive 2, so 4 is okay. But if I put negative 3 over 2 in this last one, negative 3 over 2 minus 2 is a bigger negative number. I can't take the log of a negative, so this answer is no good. So my only answer is x equals 4. So make sure when you're solving log equations, if you end up with a negative or even a positive, either way, check your values. Make sure it is going to give you a positive value for the log. All right, we're going to look at a couple word problems. So this first one is can of soda placed in a refrigerator maintains a constant temperature of 36 degrees. Here's the equation that tells you the temperature of the soda. And they want to know what is the temperature to the nearest degree after 10 minutes. So T is the temperature in minutes, and the lowercase t represents the time, and they're asking for it in minutes. So make sure your units match minutes and minutes. So T of 10 would be 36 plus 43 times e to the negative 0.058 times 10. So be careful when you put this in your calculator. Make sure you put it in correctly. And let's see, let me get it. So we got 36 plus 43 e. Remember, you don't need anything in between the 43 and the e. To the power of negative 0.058 times 10. And I get to the nearest degree, I get that the soda is 60 degrees. Okay. Then they want to know when to the nearest minute will the temperature be 45. So basically, temperature is capital T. When does this equation equal 45? So we're solving for the exponent. Anytime you're solving for the exponent, you will need to take the log at some point. And because this is e, we need to use natural log. So I need to get the exponent part of it by itself. I want this part of the equation on one side, everything else on the other side. So before we can do anything with the log or exponent, we have to do that. So we're going to subtract 36. So I get 9 equals 43 times e to the negative 0.058 t. And then we're going to divide by 43. So 9 over 43 is equal to e to the negative 0.058 t. So we got the exponent part by itself. Once we reach that, then we can do the log of both sides. In this case, again, because it's e, we need to do natural log. So remember, natural log and e cancel out. So this is going to give us the natural log of 9 over 43 equals negative 0.058 t. So t is going to be equal to the natural log of 9 over 43 divided by, because we're going to get rid of this negative 0.058, negative 0.058. Divide that on both sides. So make sure you put the natural log of 43 or 9 over 43 in the calculator correctly. It's the natural log of a fraction. And then divided by negative 0.058. And if we do that, we find out that it will be at 45 degrees after 27 minutes. Okay, and notice again it says to the nearest minute, so make sure you round off correctly. Okay, our last problem, again, we have a function. This is an exponential function, actually. We're looking at the growth of a population, and they want to know, find to the nearest 100, not hundredth, but 100, the population when t equals 3, so after 3 years. So we're finding f of 3, which would be 12,400 times 1.14 to the power of t. And t, well, we can put that in. We know t is going to be 3. So 12,400 times 1.14 to the power of 3. And after 3 years, our population is 18,400. Remember, they wanted us to round it to the nearest 100. Okay. So the second part is how long will it take the population to double? Well, let's take a look at our equation here. Here's our equation. I'm just going to copy it and bring it down here. So the 12,400 didn't quite work right. Let's try that again. Partial. There we go. The 12,400, if we start at 0 years, when t is 0, then the answer would be 12,400. So 12,400 is our starting population. If we want it to double, then that means this amount gets multiplied times 2. Well, what are we multiplying it by? We're multiplying it by this right here. So if we want it to double, that means that this 1.14 to the power of t has to equal 2. Okay? If we wanted it to triple, then it would have to equal 3, and so on. So here's really our equation. So we would want to solve for t. So it's an exponential equation. That means we need to write it in log form. So we have log base 1.14 of 2 is equal to t. And because we can't do anything with that base, we need to use change of base. So we have the log of 2 over the log of 1.14 equals t. And if we solve that, because I could say, yeah, it takes log 2 divided by log 1.14. That doesn't make sense. So this, we would need to find the value in decimal form. 1.14. And we get 5.29. Or I would say 5.3 years. Okay. Now again, this doesn't say what to round it to, but if the question did, then you would want to pay attention to that. Okay. All right. So that is section 5. No, is that section 5? Section 4. Okay. I think it's section 5. Yeah. So make sure you watch the video as many times as you want. Yeah, section 5. There we go. And make sure you get your homework in on time and be prepared for the upcoming quiz. Okay, send out an email on that. You should have gotten that already. And we will see you later. We only have one more section to go, which is section 6. And that'll be everything for this semester. So have a great day. Enjoy your videos. I'm sure you are. We'll talk to you guys later.